Hello, I am Mr. Lewis, and this is our very first video for Algebra 2. In this video, we're talking about some foundational vocabulary, some words that we will use throughout this entire year. Okay? We'll talk specifically about how to name polynomials based on the number of terms. We'll talk about like terms and what is meant to combine like terms. We're going to define coefficient and leading coefficient. We're going to name polynomials based on the degree and also explain what standard form of a polynomial is. Let's get started. First, what is meant by terms of a polynomial? Okay, when a polynomial is expressed as a monomial, meaning there's only one term, or a sum or difference of monomials, okay, each monomial is called the term of a polynomial. Okay, so this right here is a monomial. There's only one term. Okay, that's pretty simple. Okay, right here we have two terms. We have 3x squared and we have 2. So terms are separated by addition or subtraction. Okay, there are two terms in this polynomial. So this is called a binomial. Okay, bi meaning two, nomial meaning name, I think. Okay, so in this one, 3x cubed minus 2x squared plus x, we have, again, addition and subtraction separates terms. So I have 1, 2, 3 terms in this polynomial, and this is called a trinomial. Okay, now, what do you do when there's 4 or more terms? So there's, this should actually be x cubed, not x3. 2x squared minus x plus 9. There's 4 terms, okay? If there are 4 or more terms, then we have a fancy name called polynomial. Okay? Specifically, this would be a 4-termed polynomial. Okay, and really all of these are polynomials. Okay, but that's how you name them based on the number, based on the terms, and what is meant by polynomial. Okay, we're also going to talk about like terms in a polynomial. Okay, two terms of a polynomial that have the same variable symbols, each raised to the same power, are called like terms. Okay, so for example, if we have 3x squared and let's say negative 2x squared, those are like terms. I have the same variable and the same exponent. Okay, non-examples would be like 3x squared and negative 2x cubed. Okay, I have the same variables. I have x, but the exponents are different, so they're not like terms. Okay, a more complicated example might be, let's say, negative, let's go crazy. Let's go negative 1/7. Let's go ab squared c. Okay, and if I had the number 42, ab squared c. I have the same variable symbols, a, b, and c. Okay, and each of them have correspondingly the same exponents. So it's ab squared c and ab squared c. So these are like terms. Okay, it would not be like terms if I had negative 1/7 ab squared c and 42 a squared bc. Okay, so although I have the same symbols for the variables and I have a squared, a different thing is being squared. Okay, so those are not like terms. Okay, this is important because we can combine the like terms. Okay, and we'll do that towards the end of this video as well. Okay, now another really important vocabulary word for us is what is meant by a coefficient. Okay, a coefficient is the value of the numerical expression found by substituting the number 1 into all the variable symbols in the monomial. Okay, The simplest way to think about a coefficient is it's the number in front. Okay, so the number in front is 3. That's the coefficient of 3x squared. Okay, where this definition becomes important is when you have more complicated things like this. Okay, this is 4 times 3xyz. Okay, so you can plug 1 into each of those, or the way I think of it is simplifying 4 times 3xyz. If I have 4 3xyz's, then 4 times 3 is 12, and I actually have 12 xyz's. So I think of it in as I simplify it, after I simplify it, then the number in front is 12. Okay? Now, the leading coefficient is the coefficient of the term that has the highest exponent, the highest power, the highest degree. Okay? So in this case, this one right here has the highest power, the highest exponent, and it's the coefficient of that term. It's 3. Now, it's called leading because it's supposed to be in the front, like the line leader, okay? And we'll talk about that right now, talking about the standard form of a polynomial in one variable. Okay, so there's 2 ideas that are talked about here, and I'll kind of talk about both of them, okay? The most basic idea is that, I know there's lots of letters here, the basic idea is that the standard form of a polynomial is where you have the terms with the exponents or the powers or the degrees, those are all the same thing, okay, where those exponents are in descending order, okay? So for example, if I have 7x squared minus x plus 1, okay? These exponents, 2 and then, it's not written, but it's a 1, okay? 2 and then 1 and then 0, okay? There's no variable there. That's in descending order, so that is in standard form, okay? It would not be standard form if I wrote, let's say, negative x plus 7x squared plus 1, okay? Nothing's mathematically wrong with that, but just so that at the end of a problem that you and I have the same number, same answer, and that we can communicate and not have confusion, we've kind of decided on, okay, this is how we're going to write a polynomial in this kind of descending order of the exponents. Okay, another example might be, let's say 5x cubed minus 7. Okay, that will be kind of in descending order of the exponents. Okay, a non-standard example would be negative 7 plus 5x cubed, or where it's in any other order. Okay, the next idea that I'll talk about that's talked about in this paragraph has to do with the degree. Let me actually pick a better color. That's kind of unique. There we go. The degree of the polynomial in standard form, okay, is the highest degree of the terms of the polynomial. Okay, so in this one, the degree is 2. It's kind of big. Let me kind of change this to be a little thinner. Okay, and this is a second degree. This right here is a second degree polynomial. Okay, this highest exponent is 3, so it's a third degree polynomial. Okay, it's very easy in standard form to look at the very first term and say, yep, I know the degree. Okay, if it's not in standard form, you have to look around a little bit and figure out, okay, the highest degree is this one. So this is a second degree polynomial, and this is a third degree looking for that highest exponent. Okay, similarly, as I discussed a little bit earlier, the idea of coefficients and leading coefficients. Okay, so the leading coefficient is the coefficient in front of that term with the highest exponent. Okay, if it's in standard form, it should be in the very front, which is why it's called a leading coefficient. Okay, if it's non-standard, you still have to look for it, but it's still that coefficient of that term with the highest exponent. Okay, so how many terms does this polynomial have? Well, I see 2 terms separated by an addition sign. So there are 2 terms in this polynomial. and we call this a binomial. Is this polynomial in standard form? Why or why not? Well, for standard form, I'm thinking about the exponents, the degrees of those terms, okay, the powers, and are they in descending order? Well, are these in descending order? And the answer is yes, they're in descending order. So is this in standard form? And the answer is yes. Okay, the degree of this polynomial is the highest exponent, which is a third degree polynomial. What kind of polynomial is this based on the number of terms? I have one term, so it's called a monomial, and the coefficient is the number in front, so the coefficient is 3. Is this polynomial in standard form? Why or why not? Well, looking at this, I'm looking at standard form. I'm thinking about exponents being in descending order. This is not in descending order, so the answer is no. Okay, the leading coefficient is the coefficient of the term with the highest exponent, okay, and it's actually going to be -4, okay, and you think about that sign as well. If it's negative, the leading coefficient is -4. Okay, which are like terms, okay, in this polynomial? Well, like terms, I'm thinking about the same variables and the same exponents. Okay, so I have x cubed, I have no other x cubes. Okay, I have -2x squared, and I have a -3x squared. Notice I'm taking that sign in front as well. I'm thinking about the whole thing as a -2x squared and a -3x squared. All right, 3x has a like term with x here. And then I have -6, a like term with the -1. Okay, so let's combine like terms, combine the ones that are the same. Okay, so I'll start, and I will do this into standard form, which means I think about it with the highest exponent first. So I have 5x cubed, and then I think about these two terms with the highest exponent. So -2x squared minus 3x squared is how many x squareds? Well, if I have -2 and then I go 3 more negative, it's even more negative than before, and it's -5x squared. Okay, and then if I have 3x and then x more, if I have 3 and I add 1 more x, then I have plus 4x. And then if I'm at -6 and I subtract 1, then it's even one that's even more negative, so it's -7. This is this polynomial in a simplified standard form. Okay, what is the degree of this polynomial? Well, it's the highest exponent, which is 6. This is a 6th degree polynomial. Okay, let's combine these like terms. Again, we are looking for like terms and we're combining them. These two are like terms. They're the same variable, the same exponent. If I have 2x cubes and I add 3 more x cubes, then how many x cubes do I have in total? Well, I have 2 plus 3 or 5 x cubes. Okay, y to the 4th minus y squared, those have the same variables y, but they have different exponents. Okay, one's 4 and one's squared. Now, the reason that's important is because this one is y times y times y times y. This one is only y times y, and those are fundamentally different. If I plug numbers into y, I'd get different numbers. Okay, these are not like terms, so I can't simplify it any more than it already is. All right, x cubed minus 3x, x squared minus 3x cubed minus 5x squared plus 6. Okay, well, are there any like terms? Well, I see I have an x squared here and a negative 5x squared there. Those have the same variable, the same exponent, so they're like terms. Okay, and I'll write these in standard form, meaning in descending order of the exponents, which means this term has to go first. 3x cubed and then x squared. So if I have x squared and I take away 5x squares, then I'm left with how many x squares? Well, I have 1, take away 5, I have negative 4x squares plus 6. Okay? All right, so in general, we will keep the common base, okay, and add or subtract the coefficients. Okay, the exponents of the variable must be the same to combine like terms. Okay, this video introduced some foundational vocabulary that we will use throughout this entire year about polynomials, how to name them based on terms or degree, what is meant by standard form, and how to combine like terms. Thank you so much for watching.